Hello, everyone. In this session, we'll talk about what's new with Spark on Google Cloud, and more importantly, learn about some experiences from Deutsche Bank. I'm Abhishek Kashyap, Product Management Lead at Google Cloud, and with me today is Balaji Maragala, Director of Big Data at Deutsche Bank. Let us start with a look at open source. 99% of Fortune 500 companies use open source software today, and 80% are planning to further increase adoption over the next 12 months. And if you follow some of the open source projects online, you'll see that open source adoption in data analytics is also increasing very, very rapidly. And as companies migrate to the cloud, they are integrating open source analytics and processing into their core data strategy. And what that means is that they expect the same ease of use, scalability, and security from their open source platforms as from other cloud services. Just because it's open source, it does not mean that it can have a lower quality of service or security anymore. It has to be the same that the enterprise is willing to accept for all services. At Google Cloud, we have long focused on enabling customers to modernize their open source deployments with Dataproc, our managed data analytics offering for open source data processing. Customers like Metro, Broadcom, and Vodafone have been using Dataproc as their open source data analytics platform. This has simplified their operations, lowered the support and infrastructure costs, and most importantly, provided a significantly better experience to their end users. And as we have been on this journey for over 6 years, we have learned a lot from helping customers migrate some of the largest on-prem Hadoop deployments in the world to Google Cloud. And one of those learnings is the growth in Spark. And as the Spark usage has grown, we have been focused on delivering the best Spark experience on Google Cloud. At Next, our annual conference last year, we announced that we are doubling down on Spark, our commitment to making Spark a top-level solution on Google Cloud for all of your workloads: ETL, data science, and exploration. The core of these offerings is Serverless Spark. Serverless Spark is the cornerstone of what we call a modern cloud service, because no one wants to manage clusters in the cloud. And this enables users to move away from infrastructure management and focus solely on their code. Now, just having a serverless data processing engine is not enough to unlock the different use cases. We know that different users prefer different interfaces. To address that, we have made Spark pervasive by integrating it with BigQuery, which is our data warehouse, Vertex AI, which is our data science platform, and Dataplex, which is our platform to build data fabrics. With these integrations, users can seamlessly use Spark from their interface of choice. And they do not have to create clusters in advance to do any of their work. And finally, we know that one size does not fit all, so we provide flexibility of deployment. Based on your needs and strategy, you can use Spark as serverless. You can deploy it on Kubernetes using Google Kubernetes Engine, or you can create managed compute clusters, and you can use Spark on that, which is what we have been doing for the last 6 years. Now let us look at what's new since this announcement last year. First, Serverless Spark is now generally available. We have seen strong adoption from our customers for their Spark-based data processing pipelines. And we also have partners who are ready to work with you in implementing Serverless Spark within your environment. Second, we are excited to announce that we now support interactive development through Serverless Spark as well. For organizations looking to use Spark for data science and machine learning, we are launching support for Serverless Spark sessions. This enables data scientists to develop on demand without provisioning clusters in advance, which in a lot of cases is an act of going to an IT team and getting resources provisioned. So this frees up the IT team from having to deal with these ad hoc capacity demands, and users can be productive by developing through their notebooks whenever they want. The serverless Spark sessions have been natively integrated with Vertex AI, which is our unified AI platform. The first integration is with Vertex AI Workbench, which allows data scientists to use Jupyter notebooks with serverless Spark without having to set up clusters in advance or anyone needing to write custom glue code to make the two work with each other. With a single click, a user can start a Spark session and do interactive development. Now, when you use Vertex AI Workbench, Spark can easily be used together with other common machine learning frameworks like TensorFlow, PyTorch, Scikit-learn, and BigQuery ML. And since these are Google Cloud products natively integrated with each other, all the security, compliance, governance, and IAM policies that you define are automatically applied across Vertex AI and Spark, and all the way down to data access in BigQuery or Google Cloud Storage. Now, once you are ready to deploy these ML models, you can now schedule serverless Spark as a part of Kubeflow-based AI pipelines. And that brings Spark into your MLOps process as well without any complexities of cluster management. So your ML engineers who are using Kubeflow can easily start having components which run Spark in the background without any infrastructure management. And the support for these in our managed AI pipelines is also generally available. Now let's look at a demo of using serverless Spark through Vertex AI Workbench notebooks. What you see here is a Jupyter Lab UI within the notebook. You will start seeing a new tile for using serverless Spark. And once you click it, it will ask you for some basic options for starting your Spark sessions. And there is no cluster that is running in the background. The session will start. Once you click this tile, you will have an option to use it as a single user notebook or use it with a service account, so then you can share it between users. You can provide network details here, and within advanced settings, you can provide a link to a custom Docker container if you want to, say, add more libraries or customize the underlying image. And you can also select from one of the existing containers within Vertex AI. And once you click done, it will create the serverless Spark session. And once it's created, you can start using it from the notebook, and everything will work behind the scenes in the serverless Spark session. I also mentioned BigQuery earlier, which is our petabyte scale serverless cloud data warehouse. We have now integrated a PySpark editor into the BigQuery console, and that is powered by the serverless Spark backend. Now, data warehouse users can write and submit PySpark code from within BigQuery, and they will get the same serverless auto-scaling experience as they get with BigQuery SQL. So with that, you can now go to BigQuery and you can use either SQL or PySpark for doing your analytics on BigQuery data. And last but not the least, we are excited to announce that Dataproc on Google Kubernetes Engine is now generally available. With Dataproc Spark on GKE, you can deploy a GKE cluster, leverage the scaling capabilities that GKE brings, and use Spark with all the security and compliance features of Dataproc. And if you're standardizing on Kubernetes, this brings Spark to your Kubernetes environment very, very easily. We have had some strong adoption by customers for this feature during preview, and this is now generally available for you to use. If you're interested in some hands-on demos, please view the sessions from Spark Day at Google Open Source Live. Our engineers and developer advocates have put together some exciting content that can be very useful to get you started. With that, I would like to welcome Balaji from Deutsche Bank to share some thoughts about their data strategy and experiences with Serverless Spark. Thank you, Balaji, for joining us. To start with, can you please tell us a little bit about yourself, Deutsche Bank, and your group?
Thanks for inviting me, Abhishek. Hi, everyone. This is Balaji Maragala. I'm leading data and analytics platforms at Chief Data Office in Deutsche Bank. Deutsche Bank is a leading German bank with a global network, which consists of corporate bank, investment bank, private bank, and an asset manager called DWS. Deutsche Bank has presence across more than 50 countries with a large number of branches across the world and around 84,000 staff and managing more than 1.4 trillions in assets. Deutsche Bank also has more than 100 petabytes of data that we manage. And thanks, Abhishek, for having me to share my experiences.
Thank you. What is the landscape for data at Deutsche Bank? And what are some of the top challenges and learnings from your journey so far?
So the data landscapes in Deutsche Bank is made up of more than lots and lots of transactional systems and analytical platforms, and which are used across different business units. The operational data stores are made up of relational databases, transactional systems, and distributed event streaming platforms for real-time data events which are processed across different systems. The major data platforms which we have are around data warehouses based on Oracle Exadata platforms and Hadoop clusters, which are managed for data lake environments. Analytics, AI, and ML platforms are managed by centrally managed Jupyter Hub platforms and varied reporting platforms based on Tableau, Click, and we also have a lot of microservices serving these applications for analytics, utilizing both front to back aspects of the systems. The major challenges faced by Deutsche Bank are around infrastructure scaling, where we run large amount of central platforms, which are utilized by various business units, and upgrading those platforms to have latest and greatest software, and also managing the stability of those platforms with upgrades, dealing with capacity planning issues whereby we need to balance idle capacity with utilization to manage and derive value from the infrastructure, and also managing performance for various workloads running across BI reporting, management reporting, and data science workloads.
Thank you, Balaji. To address these challenges, can you please tell us a bit about your data strategy and your experiences with Serverless Spark?
Sure. Deutsche Bank's data strategy is enterprise-wide strategy whereby we want to make data an asset and drive value for our clients. We are planning to do that by enabling serverless capabilities as part of our cloud journey, where we want to encourage and enable citizen development by providing self-serve data infrastructure and also provide secure and governed access, which is consistent across all business units and all use cases across the bank, and accelerate innovation use cases by enabling best-in-class cloud capabilities for our various user personas, such as data scientists, analysts, report developers, and normal engineers as well, including business users. The way we wanted to address that from as part of our transformation is started looking at what workloads do we run on-prem, and we started engaging Google with early partnership to uh, enable serverless Spark workloads. And we run a massive Spark workloads on-prem, which range in thousands of jobs, which prepare data for various workloads, ranging from data science and normal day-to-day regulatory reporting and anti-financial crime use cases. These Spark workloads currently we have are around based on Spark 2.4, which we are looking to migrate to data proc environments. And to do that, we are following the classic re-architect, re-host, and re-platform use cases. Where we have re-architect use cases, we are looking to utilize the latest serverless Spark adoption, which requires Spark 3.x code base, and which means that we don't have to rehost or re-platform our existing code base, uh, which can be moved into Composer plus data proc environments, which we are creating. Uh, Based on these kind of transformations, what that would allow our data community is to uh, utilize consistent migration pathways and consistent access across use cases. We are also looking at integrated security provided by Google platforms in terms of encryption, authentication, and authorization capabilities, which are very important as a bank for dealing with personally identifiable information. In terms varies across like person Jupyter notebooks. Currently, we run massive central Jupyter Hub notebook state. We are looking to decentralize it and federate it as part of our transformation, which we by looking at adopting Vertex AI integration into Serverless Spark. We're also looking at various other integrations whereby we have massive transformation program underway where BigQuery is our central data warehouse capability, which will be provided across business units, and the notebook capabilities provided as part of BigQuery and Data Proc Workbench, which would enable multiple use cases and catering multiple personas, such as data engineers and data analysts who can interactively develop their pipelines, validate their data sets, and then deploy their pipelines according to our SDLC pipeline processes. So overall, bringing it down, the whole transformation, we are very much excited and we are well underway to deal with these things.
Thank you, Balaji. Quick question on serverless Spark. Based on your experience of using it, what are some of the benefits that you see from serverless Spark?
The major benefits which we see are around addressing our challenges, which I discussed earlier, in terms of like infrastructure management would be reduced massively. We don't have to manage any infrastructure uh, because the serverless Spark jobs would be self-managed, and the scalability and the performance of the jobs will also would be reduced. The challenges around managing the constant race between utilization and capacity management use cases would also be eliminated by moving into uh, Serverless Spark and using various integrations with Vertex AI and BigQuery. What that allows us is like, we can focus less on infrastructure management and more on dealing with the business problems and providing value to our clients by prioritizing business use cases.
Thank you very much for sharing that. And thank you, Balaji, for your and your team's partnership and for sharing your perspectives with the audience today.
Thanks, Abhishek.
To wrap it up, we have some content for you. If you do want to learn more, you can visit our website. You can sign up for the private previews that we mentioned today. Our partners can do a Hackfest style workshop with your own use cases if you are interested about those. And finally, for the GA products, you can just go to our documentation and get started. Thank you everyone for your time today.